going to take the mechanical properties of material. Why I am studying the mechanical properties? These are the behavior of material, how it will be behavior when applied in the load or force or temperature, whatever it may be. Then behavior of material, how it will like. So what are the properties are followed in the mechanical properties? First thing, the mechanical properties of material, it's defined the behavior of material under the action of external forces. That is called maybe load, it may be point load or UDL load, that is uniformly distributed load or uniformly varying load. And other than that, maybe the load it may be vary from with the pressure or in thermal temperature like this. Any one forces can be applied, the material property will be changed. Next, the area measure of strength and lasting characteristics of the material in service of good importance in the design of tools, then design of machines and then structures. Structures may be column or beam, it may be either like that. The mechanical properties of metals determine the range of usefulness of the metal and establish the service of that is expected. The properties are also useful for helping to specify and identify materials that mainly used for the identify the materials. How it may be ferrous materials or non-ferrous material, that's like this. That the most common properties considered in mechanical strength. First one, the important factor main is strength, hardness, ductility, that is ductile material, brittle material, toughness, stiffness and impact of resistance. Okay. Next, the list out of the properties of the materials. The following are the mechanical properties of the materials. One is strength, elasticity, plasticity, hardness, toughness, brittleness, stiffness, ductility, malleability, cohesion, and impact strength, fatigue, grip. We deeply discuss in fatigue after completing the basics of the material, properties of the materials. Okay. Next, we discuss in the first thing, that is strength. I already told you the important factor of mechanical. The strength is very important because we avoid the failures. Okay. The strength is the mechanical property. It enables metal to resist the deformation when applying external load or internal load. The strength of material, its capacity to withstand destruction under the action of external load. The stronger of the material, greater than the load, it can be withstand. It may be internal load or an external load, may it's pressure or temperature. It may be anything, any load. It will be affected properties of the strength. Next one is elasticity. Elasticity normally defined, that is the retain the shape. For example, rubber band, see that the elastic band. According to dictionary, the elasticity is the ability of an object or material to resume its normal shape after being stretched or compressed. Stretched, it may be it's a tensile, the compressive load it will be compressive. The tensile load it may be extend that area and then it also enable the length. But compressive to reduce that area, it also reduce the length. Likewise, when the material has load applied to it, load causes the material to deform. Normally, when applied the any load, it may be material it will be deformed. The elasticity of material, it's after remove the load, it's come to an original position. That also the deformation also it can be released. When stress or load is applied, it can be changed the shape. When the load is removed, it comes to the original state. That is the elasticity. For example, I see that the example. Next one is plasticity. Plasticity, you see that the shape before that you consider the pin. After using the load or something very external shape, it will just start the recover that original shape. See, that is the plasticity. The plasticity is the material. It's the ability to undergo some permanent deformation without rupture or brittle. Plastic deformation will take place only after the elastic rate has been exceeded. The pieces of evidence of plastic action in structural materials are called yield, plastic, flow, or creep. Creep also is the one of the plasticity. That also is the failure cases. Materials such as clay, lead, etc. are plastic at room temperature and steel plastic when at bright and red heat. These are all the plasticity. Next one is harness. Harness. Harness is that ability of material to withstand the load for any cutting or penetration or scratching. That's it. For the definition is the resistance of material to force penetration, bending. That is harness. The harness is, in another words, the harness is the ability of material to resist scratching, abrasion, cutting or penetration. Harness indicate the degree of hardness of material that can be imparted, particularly steel, by the process hardening. To determine the depth of and distribution of hardness is introduced by the quenching process. Quenching is process is a heat treatment process. There are many processes there for heat treatment, tempering, hardening, and then annealing. Annealing is the quenching. That is the one of the cooling process. For example, of hardness, diamond is a very hardness. Okay. Next, toughness. Toughness, it is the property of material which enable it to withstand shock or impact. Toughness is the opposite condition of brittleness. Okay. More toughness may be considering a concrete structure, for example. That concrete structure is a more toughness material because of the factor of safety is considered very high compared than mechanical and then aero other field. Civil having a more factor of safety, so the toughness also it will be increased. That is also the one of the help to improve the life of the material for toughness. The toughness is maybe considering the combination of strength of the plasticity, the manganese steel, wrought iron, mild steel, or etc. Example of the toughness of material. The concrete structure, concrete also in a that is the composite material that is also gives under that it comes under the toughness. Next, brittleness. Brittleness, it is the when applying the load it's go for a permanent deformation. That is an brittle material, for example aluminum, that is a brittle material. The definition of brittleness, the property of material which enable it to withstand the permanent deformation. The example of a cast iron, glasses are the example of the brittle materials. They will break rather than the bend under the shock or impact. Sudden, when applying the load, sudden load it will be broken that material. For example, aluminum is a ductile material. Generally, the brittle materials have high compressive strength but low tensile strength. That is the main difference. Brittle materials have high compressive strength but low tensile strength. Tensile it may be elongation. Okay, here we consider the elongation. That is the brittleness. Next, stiffness. Stiffness, it's also the one of the mechanical property. The stiffness is the resistance of a material to elastic deformation or deflection. To resistance of a material to elastic deformation or deflection. When the material which suffers light deformation and loader has high degree of stiffness. For example, high deformation, very load is very less degree of stiffness. That is the modulation of this stiffness. The stiffness of structure, it's an important many engineering application. Those that they may consider the modulus of elasticity. For example, spring. Spring, it happens that more stiffness material. When applying the load, it will be absorbed. When it will be released, the load it comes to the original. Okay, spring is the one of the best example of stiffness of the material. Also in the rubber also, rubber material also considering for bed, using bed pillows, that is also stiffness material. Next is ductility. Ductility is a property of material which enables to be drawn out into the wire. Mild steel, copper, aluminium are the good example of ductile material. When it's applied continuously, repeats the load, it will be break. Otherwise, it cannot be break. That is the ductility of material. Next property is malleability. The malleability is a property of material which permits to hammered or rolled into, for example, thin rolled materials, wires, and then tubes that are the complete required shapes and size. For example, tin for cold drinks tin boxes, and then water bottles. They are like that malleability. For aluminum, copper, tin, lead, etc. are example malleable materials which permits to be hammered or rolled into the seats. That is the malleability. That allowed to permit to required shapes, maybe rolled or hammered. Okay, here see that example. That is the malleability. Next one is cohesion. Cohesion. That is also is one of the mechanical property. It's a property of a solid body by virtue of which the resist from being broken into fragment. So that is a solid body, maybe the composite or combined or deformation body. That is also in that resist from the being broken into a fragment of the cohesion. Next, impact strength. The ability of material to resist applied the sudden load. For example, you are traveling in that vehicle and continuously in the 60 kilometer or 80 kilometer. When it suddenly applied the load, or the here load, it will be mentioned in the brake. Okay, that is one of the example. So that the places the impact force it will be applied. So the impact strength is the ability of material to resist suddenly applied load. That is the impact strength. For example, impact strength considered for the civil buildings and then aerostructures, automobiles. There are many fields used in that impact strength of the impact strength ratio calculations. Next one is fatigue. Fatigue is the long effect or it's a continued or repeated cyclic process. For in simple ways, fatigue is the continuous or repeated cyclic process. It may be uniform load or varying load. There are two categories. It having the under considered the low cycle fatigue and then high cycle fatigue. It will discuss in the latter. But now it will be the what is the definition. The fatigue is the long effect of repeated or straining action which causes the strain of or break of the material. It is the term used in fatigue to describe fatigue of material repeatedly applied when external forces are the forces may be like internal forces, external forces, or in maybe in temperature also it will be considered. Creep is also one of the fatigue. Next one is creep. Creep is a slow progressive deformation of material with time at a constant force. Here is considered uniformly forces. The creep is the slow and progressive. Creep is a slow and progressive deformation of material with time at a constant force. Here creep should be considered required time. It is a simple type of creep deformation is viscous flow. For example of the viscous flow. Some metals are generally exhibiting creep at a high temperature. That is also I already told the forces may be like temperature or pressure or external forces. Here at a creep at a high temperature, whereas a plastic, rubber or similar amorphous material are very tempered at the sensitivity to creep. Okay, when you apply the high temperature, the plastic means normally it will be tempered. So it's a sensitive to grip. The force or specified rate of strain at constant temperature, that is called grip strength. That is the basics of the mechanical property. I repeated it. The list out of the factors are influencing the mechanical properties. One, strength. Second, elasticity, plasticity, hardness, toughness, brittleness, stiffness, ductility, malleability, cohesion, impact strength, fatigue, grip. These are all the factors influencing the mechanical properties. Next, how it will be defined and then examples. Here now it will be, I give some examples of the mechanical properties. Okay. So that is the classification: elasticity, plasticity, ductility. That is the one of the classification. Malleability, hardness, toughness. Already seen what is malleability. So elasticity means it does not recover the original shape. It's regain the original shape. Plasticity, it does not recover the original shape. Ductility, the ability of material to withstand the force. Malleability, that means hammered or rolled. Hardness, also the resist the impact resistance. Toughness, also to resist the internal or external force. Brittle material, tenacity, fatigue. Okay, these are all the classification. Before that, what is the material? Whatever the thing presents in the world, material, either physical or non-physical, as a body, mobile, laptop, book, it's all are material, physical or non-physical. Okay? What is in engineering materials? Engineering materials, that is used to raw material for any part of construction or manufacturing, is an organized way engineering application. It's known as engineering materials. So what is material science? Science in which new material is discovered or by using science in the present material. How can we effectively use it? It's called material science. Okay. Do you know the first difference? Engineering material and then material science. Okay. Engineering materials, it's a raw material, it's any part of construction or manufacturing that will be defined for engineering materials. Material science, it's a present of material. How can we effectively use it? For example, that application of we are using that for using automobile piston and connecting that. Here we are using only the ferrous material. We cannot use it non-ferrous or any other plastic material. So that is the material science, and depends upon application what kind of material is used. That is the knowledge of the material science. Next, how it will be classified the materials. It may be ferrous, metal, non-metal, ceramics. There are three main categories generally: metal, non-metal, and then ceramics. Metals, first it will be classified ferrous and then non-ferrous materials. Second one, non-metal. Non-metal materials means thermoplastic material, thermoset materials, and elastomers. That is also non-metal materials. Next one, ceramics materials. That is glasses, crystalline. For example, tiles, marbles. That is also in ceramics material. We included the silicons or some other particles. Okay. And fourth one is composite materials. Composite materials, it may be classified in metal matrix and then ceramic matrix. And fifth one, that is the polymer. So generally we are classified in five categories: metal, non-metal, ceramics, composite, polymer. Metal means ferrous and non-ferrous. And the non-metal means thermoplastic, thermosetting plastic, and then elastomers. Ceramics means glasses, crystalline ceramics. Composite, that means MMC, that means metal matrix composite, and then ceramic matrix. And last one, fifth one is polymer. Next one is properties of material. How it will be materials, how it will be classified. One is mechanical properties of materials, We already seen that mechanical properties previously. Okay, and then electrical properties of material, physical and chemical properties of material. So totally three categories are included the properties of material. That is mechanical properties of material, elastic properties of material, physical and chemical properties of materials. First one, mechanical properties already we discussed in include. What are the properties are include? Strength, elasticity, plasticity, ductility, malleability, hardness, toughness, brittleness, tenacity, tenacity, fatigue resistance, impact resistance, machinability, strength, strain, resilience, proof resilience, modulus of resilience, grip, rupture, and modulus of toughness. These are all the factors are including or affecting the material. These are all the mechanical properties. Already seen that the what is it? I explained that again. Elasticity, that means when applying the load, material it will be deformed. Then again they release the load, the material comes to the original shape. That is the elasticity. The definition is the property of material from which if we pull it or leave it, then it will come back its shape and again. It is called elasticity. This property is useful for materials used in tools and machines. Next, plasticity. It is the property of material from which we pull, but it cannot be regained its original position. For example, the forging operations. Forging operations we are include the connecting rod, piston, and then wheel drum, stamping images, coin, then ornamental work means jewels like that. Next one is ductility. Ductile are strong and plastic material. For example of ductile material, mild steel, copper, aluminium, nickel, zinc, tin, and lead. Malleability, that means rod or hammered of the material. For example, lead, soft steel, wrought iron, copper, or aluminium. Suppose the hardness. Suppose there is a metal and we have to scratch it. The harder the scratch is, the harder our material will be considered. Suppose we have a material called iron and another the side of silver aluminum. So if we impact on both, the highest impact it will be on aluminum because it is a weak material and the hardness is less. Aluminum is one of the weak material. The hardness is less. It can be easily rolled and hammered, anything is possible for aluminum. It will be more difficult to scratch on the sheet iron. We compare with the aluminum, so hardness will more be on iron. Compare with aluminum and then iron it will be more harder material. The hardness of material defined is various of tests. There are some tests to identify the material hardness. That is Bernal hardness test, Rockwell hardness test, Vickers hardness test, and then Shore stereoscope. There are four methods to identify the or calculate the material of the hardness. How it will be, for example, iron having some hardness value, aluminum having some hardness value. These are the tests are helpful to find out the hardness. Toughness. It will be bend or twist. How much of energy can absorb before the breaks or fracture. That is called toughness. The toughness of the material has been decreased when it is heated. So toughness is properties to provide the information about the capacity to absorb maximum energy. For example, we are manufacturing the gear. So first we proceed that manufacturing process for, that is the machining process for turning, turning and then drilling and then thread cutting. These are all the processes are completed. After that we send to the material for the heat treatment process. After completing heat treatment process, it will comes to a cylindrical process. That means the cylindrical grinding process. Okay. Impact test, previously tested in hardness test. Now the toughness already told, it's an impact force, that is it is sudden attack. So they find out that there are two tests for finding Izod and then Charpy testing. So first we know that the difference of hardness and then impact. Hardness is not a sudden impact load, but impact testing is suddenly applied load. That material it will be considered as Izod testing and then Charpy testing. Okay. Brittleness. Suppose we have a material and we impact and it should be broken without deform is called for brittleness, or if we pull such material break instead and it break instead pulling, if we call it brittleness. For example, cast iron brittle material. Cast iron is also the one of the brittle material. When I think applying the suddenly load, it will be suddenly break. Next one, tenacity. Such a material on which we apply pressure, bend and pull but do not break in that condition is called, for example, it can be any kind of load, it can be applied but before break, do not break. That is the tenacity. Next, fatigue is a repeated process cyclic load. I already told high strength and the low strength of the high durability, the factor of fatigue materials. For example, fatigue properties is used for observing designing shaft, connecting rod, spring, gears, etc. Causes of the fatigue material, dynamic forces or repetitive load or cyclic process. It may be load, it may be uniform load and then UVL, I already told varying load. Next one is, what is fatigue resistance? In spite of repetitive loads on the material, it is not broken, then it is the fatigue property. For example, road. There are many vehicle cross per every day or every month or every year, for every second and then every minute. So repeatedly load is applied, that is the variable load, but do not break. That is a fatigue resistance. What is an impact resistance? The material and hit with a hammer, so the more can be bear that injury, that hammer without breaking. That much impact resistance will be high. That is the impact resistance. Machinability, that is the easy can be to machining process, that is the machinability. Such a material that easy to work on cutting using tool or machining, it will be easily machinability. For example, brass is the one of the material for easily machining process. For example, brass material used in worm gears. So worm gears mainly used to gear reduction speed purpose. Okay. Strength. Next one is strength. It will be put a load on material. It is without changing its shape, or it is able to bear without breaking. In that, it is called strength. So the ability or capacity of the material will withstand support or a load without fracture is called strength. Next, strain energy. You put a load on a body or material. The body is elastic up a particular limit in the stress strain curve. So the energy that can be stored up to elastic limit called that strain energy. What is resilience? Such material in which the strain energy is stored in the body till the elastic limit only is called as the resilience. So it is the property of material to absorb energy and to resist the shock and impact load. This property of essential for spreading materials. Proof resilience. Such material in which the strain energy stored in the body till in the elastic limit only is called as resilience. So it is the property of material to absorb the energy and to resist shock and impact load. This property is essential for spring material. What is the proof resilience? how much maximum the strain energy stored in the material up to the elastic limit. It's called proof of resilience. Then model of resistance, modulus of resilience. If we divide the proof resilience from the volume of body, before that proof resilience, energy stored in the material up to an elastic limit, that is the proof resilience. Modulus means the volume of body, then it will come out with the modulus of resilience. Okay. Next one is creep. We understand the constant load I already told during the period of time. At maybe high temperature or the deformation it happened inside called creep. Creep is used to examine designing an internal combustion engine. It is applied in internal combustion engines. So internal combustion engine, there are engines having two categories. One is internal combustion engines, another one is external combustion engines. That will easily identify the IC engines, EC engines. IC engines means the fuel takes from inside the cylinder. That is why we call it internal combustion. Then the external combustion engines, the fuel takes from outside the cylinder. That is called the external combustion engines. They are already studied, but anyway I will repeat it for this interview. Also that engine boilers and then turbines. What is rupture? Rupture meaning it is a break or burst, suddenly stress rupture. Testing is similar to creep testing except that the stress are higher than those used in creep testing. Modulus of toughness. The toughness is defined the ability of material to absorb the energy plastic deformation. That is the toughness. There are three categories for toughness: milling machines, drilling machine, lathe machines. These are all the mechanical properties. So we know that mechanical properties are missing. The mechanical properties here for extra additionally we see rupture, what is modulus of resilience, then proof of resilience, and then strain energy, then machinability, fatigue resistance. So these are the tenacity. These are all the additional mechanical properties. Then previous case, now it will be seen. Next, fatigue failure. Next we causes for what is failure. So failure is when applied the repeated load, it's failure, it's a one stage. The failure due to fatigue, so we call for fatigue failure. So the outline of the fatigue failure. First we introduce that what is fatigue and how it will be called with the life of the method. There are three methods. One is stress based approach, and then strain based approach, and then linear elastic fracture mechanism. And next on endurance limit, the comparison or the study about the endurance limit and fatigue strength. And next, characterizing and fluctuating stresses, and then fatigue failure criteria for fluctuating stresses, combination of loading of modes. These are the outline. First, introduction. Already told what is fatigue. It's a repeated cyclic process manner. It may be uniform load or varying load. The load it may be alternator or repeated or they are fluctuating or repeated. Anyone that the load is applied these frequencies, it's compulsory go for a fatigue testing or fatigue correlation. The fracture at mechanism stress will below the yield strength, that is SY. Failure occurs after many stress cycles. It will be 10,000 cycle per failure is by sudden fracture. No visible warning in advance of failure. There are many failure for no invisible, no warning, no visible warning. With sudden fracture it may be happen because of due to fatigue. Okay. Fatigue it cannot be predicted, but it will be improved the failure. It can be eliminated the failure and improved the life. Okay. This is the history of fatigue. In the year of 1842, the train it will be crashed due to a fatigue. See the drawing, see the picture, the due to a fatigue. What we are explained, the first explanation of what might have happened came from William John Macron Rackham, one of the many famous Scottish physicists. He had invested broken axles. The failure purpose mainly due to of axles. That is highlighting the important stress concentration. Because of the failure, it will be loaded at the stress concentration factor, and the mechanism of crack it will be growth with repeated loading and then vibration. This means that was first to suggest that the basic mechanism of fatigue tied to vibration. The next failure, that is the Havilland crashes. The two Havilland crashes, Comet passenger jets, the first commercial jet planes in the world. They broke up in the mid-air and crashed within a few months of each other in 1954. So 1954, one more crash is that the crashes were a result. They are what the result are concluded. It will be happened on metal fatigue caused by the repeated pressurization and depressurization of the aircraft. Next one. Here are the survey for that due to fatigue failure. That is the aircraft surveys. Aloha Airlines having 243, Boeing Airlines 737 to 200 for that accident report, and then the explosive decompression caused by the metal fatigue. The fatalities that one and the injuries is 65. That is happened in the year of 28th April 1998. Here the damage of the flight, that is due to fatigue. See that first one, then second one, third one, and then last one. So because of the fatigue, there are many problems occurred in the normal life. Next, cyclic loading. It will be compare the fuselage, the air breathing structure. First one is low altitude. That means altitude is very low. The flight it get very high outside pressure. The flight is moving high altitude. The outside pressure is very less, but the inner side is high. It is estimated that an average jetliner must support 5,000 kg of force per square meter. So next, that fuselage failure part, how it will be failed, they are the analyzing. Failure analysis. According to the Boeing engineers, if desponding occurred, the hoop load transferred through the joint. Then you know that the hoop load transferred through the joint would be become one, and by 3 rows countersunk it will be rivets. The countersunk, the entire rivet heads extended through the entire thickness of the fuselage. It will be creating a knife edge at the bottom of the hole which concentrated stress, so that the stresses were cyclic with pressurization load and fatigue cracking ultimately occurred at this site. The final result is the flight it will be failure. See that the part, that is the hoop. This the hoop load is transferred through the joint. Then automatically due to the countersunk, the entire it will be. So see that the accident damage of the hoop load will act on the flight of the wheel. Next, the failure stages. There are 3 stages. They are categories A, B, C. That means initiation, and then propagation, and then finally it will be fracture. The stage 1. The stage 1 he represented A. It's an initiation of micro crack due to cyclic plastic deformation. The image it will not be clear. It will be the crack starting from the minor deformation, very less. Second stage is 2. Progress to macro crack which forms to plateau-like surface that is repeatedly open and closes. It creating a band called benchmark. When the component will be repeatedly applied the load, it will be create the band mark. See that. That is the benchmark, and also in another way they are called as benchmark. And then stage 3, The crack has high propagated area that the remaining material is insufficient to carry the load and fails by the simple ultimate failure. The final stage, the third stage is broken or failure. See that the surfaces like for consider high nominal stress and then low nominal stress. How it will be stages it will be equal. First one, the material there is no stress concentration because of there is no sharp edges in this part. Okay, see that it will be plain. The end of portion it can be bended. Okay, so that the neck it will be formation. See that stage 1, stage 2 and see. Next it will be mild stress concentration because of here it will be some internal concentration it will be acted the corner things. How it will be? The benchmark it will be maybe differ from the other two one. See that. First one, the benchmark, and then you can shape it will be tension or compression. Maybe the load it may be tensile or compressive. Anything if the load it will be nothing to do. Okay. See the difference. And next one, stress, severe stress concentration because of all the edges are not in sharpened. So all the edges are not in remove the sharpened. So here the more sharpened edges, see that the variation of the first one, second one and third one. This is the high nominal stress. Okay, here I will told that. That is outside pressure is high, there is a low order. That is the one of the example of this one. Next one, low nominal stress. The same thing. Only structures at the benchmark it will be differ or vary. Okay. Next, fracture surface due to in torsion. How it will like this? There are two categories: high nominal stress, low nominal stress. In high means no stress concentration, mild stress. That means the minimum stress concentration considered. Here heavier stress, more stress concentration it will be considered. The torsion it will be an anti-clockwise torsion because of the arrow mark is rotated the clockwise. So here they applied the clockwise torsion. See the difference. The benchmark is first one, the second one, and then third one. That angle of rotation it may be it's vary. Rotation varying. That is the low nominal stress. That means high attitude, low outside pressure. See the difference. First one, second one, third one, and then difference it will be drawing. So fatigue fracture surface in torsion. Next, for example, AASI 4320, that is the material grade. We have taken from that example of this shaft. The shaft material grade is AASI 4320, that is used for a drive shaft. The point B is a crack initiation due to a stress concentration because of here the keyway point is located. Okay. The final is it will be result it will be failure. The final brittle failure. For example, fatigue failure of forged connecting rod. See that the forged connecting rod. The crack is initiated at the flash line left edge of the pictures. See that crack initiated at the flash line. Beach marks also show the crack propagation halfway around the hole before the ultimate fracture. Okay. We can see that examples. Next, how it will be called at the fatigue life. There are three major fatigue life model is there. It will be predict the life in number of cycles failure to failure, that is N, for a specific level of loading. So depends upon load applied that it will be categorized in fatigue life method. First one is stress life method. Second one is strain life method, and then third one is linear and then elastic fracture mechanics method. First stress life method, that is NS or SN curve. Okay, it may be Stress versus number of life. That is the most important thing to find out that stress life less accurate, particularly for low cycle application. It is the most traditional, easiest to implement. Strain life method. That is the analysis of periodic materials. Detailed analysis of plastic deformers and localized regions. Several idealization are compounded leading to uncertainty in details. Linear elastic fracture mechanics method. Assume crack exists. That is the stress life method, strain life method, linear elastic fracture mechanics method. There are three methods. This is the fatigue testing machines. The first we invented RR mode fatigue testing method. See that revolution counter here. Okay, that is the test specimen here fixed. In this here located the test specimen, and then the range of the specimen values 9 into 7 power 8 inches in R. Here this part is flexible counting. The motor having the 1750 RPM, that is revolution per minute. Okay. Here the varying weights depends upon the weight. Here it will be added, or it can be removed from that equipment. The maximum volt applied 110 volts. That is the alternating current. Okay, C is an earth meter. Test specimen are subjected to repeated stresses while counting cycles to failure. The most common test machine are more high-speed rotating beam machine. The subject specimen here in this content only specimen can be measured, not in component or not in the pieces. Okay. Subject to specimen pure bending with knob transverse shear. The specimen rotates stress fluctuate between the equal magnitude of tension, compression, known as completely reversal cycle. Specimen is carefully machined and polished. See that the SN diagram, the number of cycles to failure at varying stress level. Here the number of cycles, that is here upper for x-axis, number of cycle, for the y-axis fatigue strength. The unit of the strength is megapascal or it is Newton per mm square, meter square or centimeter square, anyone. See that the low cycle and the high cycle of that. Here low cycle means here the stress value is high, life is very less, and high cycle stress value is less, then life value is increase. Which one is best? It means the finite life. That means the 10 power 2 square to 10 power up to 10 power 6. The intermediate position, that is the finite life of the material or any component. Okay. So here it will be the infinite life. It may be cycle, it will be increased 10 power 8, 10 power 9 up to whatever it be. Next one, the SN diagram. So SN diagram also it is stress life diagram, here strain life diagram. So we are considering the endurance strength. We are considering only the strength. Okay. Endurance means the finite life is that endurance. That is the infinite life is an endurance. Okay. So stress levels below the SE means endurance strength. Predict the infinite life. Between the 10 power 3, the cycles 10 power 3 to 10 power 6, finite life is predicted. That is that below the 10 power 3 cycles known as low cycle and is often to consider quasi-static healing usually occur before fatigue in this zone. The same thing, fatigue strength, the number of cycle, here consider the endurance strength. Endurance strength it will be stress strain, not here the stress, only strain and the life of the material. That is the SN diagram for the non-ferrous material. See the difference. Sand casting is in very less cycles, less stress value, getting that more life. That is the permanent mold casting, the stress range is 282 up to 420, the stress value. The wrought iron having more than 422 to up to 560 stress yield strength are in the megapascal, 5 up to 560. So sand cast iron, the value is between 210 to 245. Permanent mount iron is 280 to 350. The rod cast iron is, or the rod iron is 420 to 560. That is the main difference of the SN diagram for non-ferrous materials. So stress life method, strain life method use a detailed analysis of plastic deformation and localized region. Compounding of several idealization leads to significant uncertainties in numerical result. We already know that the big point of the stress strain there, that is hysteresis loop. From point here, the first reversal and then second reversal, third reversal and then fourth and then fifth, 25 reversal we consider. The position A, B, the for x-axis for considering the sigma, that is the difference, that means difference of the strained range, that is the delta sigma. Delta E, here the delta EB equal to delta E. That is the formula for calculate that stress line method.